Okay. Hello, everyone. Today, let's talk about Keystone Federated Authentication. So, what is Keystone Federated Authentication? Federated identity provides a way to securely using existing credentials to access cloud resources such as servers, volumes, and databases across multiple endpoints. These endpoints were provided in multiple authorized clouds using a single set of credentials. The credential is maintained by user's identity provider. The identity provider stores users' information. It could be another Keystone. It could be another Keystone service too. Here, OpenStack works as a service provider. So why we should have identity federation? So there are three reasons. The first one is erase the burden, transfer the certification work to third party. Convenient and flexible with Web SSL login, the user can access different service providers such as AWS or Big Cloud in China Mobile. The third reason is security. Service provider do not need to store users' information, and we can choose our trust identity providers. There are several protocols supported in Keystone Federation. SAML 2 enables web-based across-domain single sign-on, which helps reduce administrative overheads of distributing multiple authentication tokens to user. OIDC, which means OpenID Connect, use OAuth protocol and already has a number of business in use. For example, both Google accounts and Microsoft accounts system support OIDC. Kerberos was created by MIT and the solution to these network security problems. The Kerberos protocol uses strong cryptology so that its client can prove its identity to a server or vice versa across an insecure network. In this page, let's introduce some important concepts in Keystone Identity Federation. The first is service provider. It means a system entity that provides services to principal or other system identity. In this case, OpenStack identity is a service provider. Identity provider, IDP, a system entirely that authenticates the users outside service provider. Mapping adds a set of rules to the map federation protocol attributes to identity API objects. In Keystone, it maps the federated user with groups. Protocol contains information that dictates that which mapping rules to use for an incoming request made by an IDP. Unscoped token and sum assertion and claim is used for different protocols. If a user has been authenticated by an IDP, then the mapping related with the protocol will work. This picture depicts the authentication protocol or principle of SAML 2 federation in Keystone. Remote user is authenticated by identity provider, and with the protocol SAML 2, it will produce SAML assertion. Then the Apache server handles the assertion and exchange it for local user. This is a detailed process. Let's just skip this. This picture describes the user case in China Mobile. A user registered in Guangzhou resource pool, and he wants to access another resource pool in Beijing. It needs authorized from third-party plugin components, which here may be a mode strip or mode OpenID, or mode herb. This can be set in Apache. This can be set in an Apache server. There is a similar scenario. I have buy a resource pool in China Mobile, and I want to use the resource in AWS, but I only want to use one account to log in AWS for security reasons. So in this situation, I may choose this federation. Here we just show the important part in our federation test. And then next page we will show, this page shows the components that we need to install and configure. And next page we will introduce the local settings. In the service provider part, the most important design is mapping. Here we give every federated user a unique project. Also, we can assign him the role in the project. Here is a tenant admin. And in our cloud system, tenant admin can have the whole access control to his project. While in the IDP part, we should set the service provider URL and auth URL for service provider. SP URL is just for assertion-based verification, and auth URL is authentication of federated assertion and exchange it for token. This page shows a test between Keystone Federation and Keystone Authentication natively. The process of Keystone Federation is a picture in the left. One identity service in Guangzhou works as IDP, and we set only one node for test. After the IDP authenticated the user and produced the assertion data, which will be passed to the service provider for exchange. The service provider exchange assertion data for unscoped token, and then user use it for scoped token. For the mapping in the previous page, each federated user has a mapping project in service provider. So here we can get a scoped token. And the picture in the right shows getting a token natively in service provider. We designed the test process similarly, so and we will show the result in the next page. So let's see the result. In this test, we want to find the upper pressure limit of identity service in service provider. From the result, we can see if there is more than 915 requests for tokens simultaneously, errors will happen. First, we set the request number is 900, and do the pressure test. The result is all successful, and we found that. So we believe that 900 requests for token spend is okay, in our test we find that we request 900 simultaneously. We spend almost the average time is 97 seconds. The biggest time to spend is about 93 seconds, and the shortest time is about 8 seconds. Then we increase the number and set it to 915, and so we get 5 errors. So at the pressure, it can bear seems to be 900 requests, and we found 950 requests for token spends about 96 seconds. So the biggest time to spend is about 93 seconds. From this test, we assume that the upper pressure limit is about 915. So the following test we will based on this result. compare page 12 and page 13. When the pressure are lower than 915, the success rate is almost the same, but the total spent time is increased. The reason may be the performance limit. So we just using federated authentication may not relieve pressure. We may use a mixed model. So let's see another test. This page shows another test. The total request is about 915, but half of the requests are from Keystone to Keystone federated requests, and another half are from identity server in service provider. We do the two requests at the same time. From this result, we can see that federated identity is all successful, but the local authentication in service provider has 14 errors. This test tells us when we set the mix authentication like this, the local pressure is still there and worse. So we adjust the parameter again, and let's see another test. This page shows another test. The total request is still 915, and about 615 is Keystone local identity in service provider, while there is another 300 is in Keystone to Keystone federated request. We found that 300 federated authentication requests are all successful, but in local identity of service provider, there is more than 100 errors. This is confirmed that the pressure in the service provider is larger. So we should set the appropriate parameter. For the previous page, we see 14 errors, and here were more than 100 errors. So this shows more federated authentication will relieve the stress. Then we did another test in the next page. We set more authenticated requests. Compare the above pictures. This test shows a best result and only one error. This tells us when hybrid authentication is used in OpenStack, we should anticipate the use of pressure and set suitable joint certification and local certification. This is also shows federated authentication can help relieve pressure. With Keystone Federation, to users, he can manage one user account and log in to many different clouds. It's very convenient and flexible. Let's skip this. These are some details about OIDC and Kerberos, and I think we should, due to the time limit, we skip this part. And let's see the analyze between these three federation protocols. We compare the above three types of federation protocols. We compared these from 4 aspects: security, interoperability, complexity, and applicable. And from this table, we can find OIDC is most commonly used, and the Kerberos is most security. SAML is less security and few users to use this. Okay. This page we will show our federated practice in federated authentication. The above diagram is our main design. We use our email system in China Mobile to verify the user, and then he can log in into the OpenStack by his email account. We set a server phone in the LDAP, which is security assurance. Each request from the user, the server phone is responsible for the security. We designed a SMP protocol which means the short message protocol. Each IDP should first register the server phone number in the service provider, and then the service provider and identity provider build mutual trust through this. Also, the user would use it to request to service provider. This page, we will share our federated authentication processes. First, the user wants to access to the service provider, and now Keystone has supported Web SSO. Then the service provider redirect it to the identity provider. Here is our own web with email system in China Mobile. Next, the identity provider requests to the service provider to build mutual trust. The service phone, the server phone here works as a service provider. Produce an authentication code and returns it to server phone. The server phone sends it to the user, and the user log into the identity provider. User uses his secret to encrypt the authentication code. After the user log into the identity provider, the user uses his secret to encrypt the authentication code. The identity provider then uses this user's secret to decode the authentication code. Then identity provider returns the authentication code to the service provider, and the service provider verifies it and consider it is a legitimate request. At last, service provider map it to federated user. Then it returns a session with token to the user. Here is an example that we use our email system as an IDP. So you see it's worked on Horizon. Okay. If you have more questions, you can feel free to contact Yang Weiwei, and she is our chief Keystone developer in our team. Okay, thank you. Thank you.